We'll pay some extra credit for this if you'd like. So they give us a function called f. That's just a table. There is a very specific reason why you cannot say that the minimum value of f on that interval 0 to 4 is 2. We'll give away some full tickets for this because it goes quicker. So somebody raise your hand and tell me, what's the reason? Look up. Okay. Some people are getting better at this than others, but you've got to get a lot better at like understanding ideas, concepts, and then using them to answer questions. You've got to get away from using questions to answer questions. That's not going to succeed in this class. It's got to be ideas to answer questions. So Logan, what's the reason why A has to be false? Or I shouldn't say has to be, but it could be false.
It's a table with selected values only, so you're not seeing every single point.
So Logan just said, I'm just going to say it again for the video. Logan said, when you look at a table of selected values, there's a whole bunch of y coordinates you don't see. So even though the lowest y coordinate of the one shown is equal to 2, that doesn't mean there couldn't be some other y coordinate that's absolutely lower. Okay? Question. We'll pay Logan a ticket for that in a minute.
Oh, never mind. I didn't have a question.
B is exactly the same logic. Exactly the same logic. Question. Is that bothering anybody? Please.
One thing I'm wondering is that, like you said, it would be a y coordinate that's lower, but it's this minimum value of f on 0, 4. Like, so, like, isn't that the lowest one on 0 to 4? Or
No, good comment. So here's the piece you're missing. I'm going to ask you a question. I think if I ask you the question, you'll know the answer. What's the y coordinate of f at x equal 1.5?
3.5?
How do you know?
Because it's in between 3 and 4.
How do you know that? I'm being a little sarcastic, but how do you know that?
I don't know that.
You don't know that. So is there any reason why at x equal 1.5, the y coordinate could not be this?
It could be that.
Sure. And that's why I cannot declare A to be a must be true. I can't say that A must be true because I don't know a whole bunch of y coordinates. So yes, of the y coordinates that are displayed, a y coordinate of 2 is the lowest, but there's a whole bunch of y coordinates that aren't displayed. And that's exactly what Logan was saying, and that's the big idea, that's the concept you've got to remember for all kinds of future problems. Does that make sense?
Yes.
Perfect.
And you could use that same reasoning for C, because it says that f of x has to be greater than 0 for 0 through 4, but at 1.5 it could be -2, right?
Yep. Yeah, the answer to C is exactly the same logic as A and B. We are looking at a table of selected values. So you don't make assumptions about what the missing values are unless you have other data to tell you what the missing values are. Perfect. This is awesome. Like, everyone's dialed in now, listening. Anybody have any thoughts coming to mind that's bothering you? Cool. So we go to D. D says the tangent slope of f between 2 and 4 always has to be negative. Well, Danica's chart would tell me that if the tangent slope is always negative, then f must be going down between x equal 2 and x equal 4. Someone want to comment on that?
Again, there's only selected values. So if you just take 2, 3, and 4, yes, it looks like it's doing that. Because it goes 4, 3, 2 on f of x. F of x does 4, 3, 2. But 2.5 might be 5, right? Yeah,
A, B, C, and D have exactly the same reason. Like David just said, looking at the values they gave me, the values of f, do decrease, at least the ones they give me, from x equal 2 to x equal 4. But I have a whole bunch of values I don't know. So I don't have any other clues to indicate what those other values would be. In some problems, they'll give you other clues that you can use to identify what the other values are. But, okay. There's a specific reason why this is true. I already owe Logan a ticket. This one, you have to do it yourself. You got to be honest with me. If you can tell me the exact reason why, like E is true because the others are false. I get that. But for the test that's coming up, you need to know the reason why E is true just because E is true. So if you earn a ticket for this, great. If you don't, just learn from it because you need it for the test. At least 1 or 2 questions on the test that if you don't understand E, you will miss those questions. That's why I put this on the practice test. Let's try Max.
Because f of x is increasing, and then or it is increases over time, and then it decreases over time until there has to be at least one x value where it's not increasing or decreasing. So the tangent slope of 0, which is what it says there.
So raise your hand if you honestly would have answered with basically the same thing that Max said. Okay, good answer, but I can't give you a ticket for it. It's a very logical, it's totally logical, it is. But for the AP test, there's a more specific reason you have to know. If you want to try again, that's fine. Who wants to try? Let's go Logan this time.
Is it because the f prime of c does have f prime slope? Like, as we said, the slope, so you know.
So hold on 1 second. So one thing I'm really pushing people to do now that we're getting better and better at calculus is we've got to get better and better at being very specific. So when we say f prime of c, that means something very specific. Like what does that all by itself mean?
I don't know.
Oh, no worries. Cameron.
That is the tangent slope of c. Oh my god.
Say it.
Of the white one.
Tangent slope of it.
So Sammy's got it. Where, Sammy?
X equals c.
Okay, everybody, I'm not kidding. You've got to get very specific. Like a lot of times what's holding you back, I make this little comment, and what's keeping you from getting this score and you're getting this score is you're not specific enough. Like you say things like, oh, it's a slope. Like slope of what? Like which kind of slope? Where? This is perfect. F prime of c means the tangent slope of f as specifically the x-coordinate of c. So who knows why this absolutely must be true, no doubt whatsoever. Down to 2 people, 3 people, 4 people. Try Logan again.
Is it because you know it's the slope is going, I don't know how to explain it, because you know that it's going up and down the graph?
You're okay. You're basically saying the same thing that Max said, which is okay. It's very logical. No, okay, look at me. Your logic is very good. You see the values of f go up, and then you see them go back down. So you're like, well, there's got to be somewhere where the slope is 0. There's just a more specific reason that you all must know. Try Brock.
Is it because it's continuous and differentiable, so there can't be like a pointy spot, so there would have to be a flat spot? Is that why?
Hold on. No, don't give up. Kim, I owe you a ticket, Logan. Don't let me forget. Okay, here's why Brock's getting a ticket. Look at me. Here's why he's getting a ticket. That is a really good observation because watch what I'm about to draw. Here's a chance for the whole room to get a ticket. That graph of f, as Brock said, if that graph of f was not continuous and differentiable, I could draw f that looks like this. Fair? Not if that makes sense. Raise your hand, I'll pay you a ticket. This is way too, you don't know why I'm paying a ticket for this. Just raise your hand, don't say it out loud. Raise your hand. Does that graph of f ever have a tangent slope that is equal to 0? Hands up. There we go. Brooke.
No, because if the tangent slope is 0, it has a horizontal asymptote, or like a horizontal line.
Yeah, you're all picturing something like this, right, Brooke?
Yeah.
Yeah, this type of a graph of f does have a horizontal tangent, which means the slope right there would be 0. This graph of f does not. This graph doesn't have, because of what Brock said, that's why I paid him the ticket. It was very good. If f is not continuous and differentiable, f can still go up and come back down, and f won't have a tangent slope of 0. Okay, how many know it? I'll pay in a minute. Okay, I'm still looking to pay one person you were really close, the very specific reason why E must be true. And it is definitely related to the fact that f is continuous and differentiable. Darren?
Does that have anything to do with like the mean value theorem?
Because what does the mean value theorem say?
It says that where there's going to be a spot where the secant slope is equal to the tangent slope, and since you know that you can determine the secant slope by looking at the graph right there, like the points where, for example, where x equals 1 and 3, the y both equals 3, so you can determine secant slope is going to be horizontal there, and you know that there's also going to be a tangent slope at some point.
Teachers and staff, another note that there is food in room 507 if you'd like to go down. It's leftover Olive Garden, but there's still plenty for you. So please head down and get your food for lunch.
I'm going to say it back to you because you actually did everything just right before she came on. The reason is, and you all got to get this memorized, the mean value theorem guarantees that if f is continuous and differentiable, then if you can find a secant slope on this interval, which Zarin just did, from this point to this point, the secant slope is 0. Therefore, there must be a tangent slope whose value is also 0. That's perfect. That's exactly what you've got to memorize. We want to talk more about it before we end the video. Mary?
You said that the top 4 were you said that they were false.
The top 4 are what I would call could be trues.
Okay, I just heard you say that they were like for sure false.
Oh, my bad. Thank you, Mary. No, that's a very good clarification. The top 4 are all could be trues. They're just not must be trues, and they're asking for the must. Perfect.
So why do we have to recognize the mean value theorem when we recognize it's continuous and differentiable and that it's increasing and decreasing?
Oh, listen to Max. Hey, the honest reason, because they'll test you on it.
Okay.
Yeah, I've seen this little method here, like show a table. I haven't seen a lot of questions that were multiple choice like that. I've seen quite a few that were written just like this. And they're just, it's one of the reasons, it's one of the requirements for the AP test that you have an understanding of the mean value theorem. That's how they tend to test you. So that's all. To me, the mean value theorem is kind of like what you said. It's a common sense theorem. It's like, I don't care that I can't remember the theorem if I remember the idea good enough for the future, but they will test you on it. So, is that okay?
Yeah.
Good work.
Can you just say like the thing you said about the mean value theorem again?
Uh-huh. So you all should have a flashcard for this. If you need a flashcard, I'll pass them out. Anybody need a flashcard? There we go. I thought of you. Anybody else? Hands up. Anybody else? That's 20. Anybody else? So on one side of the card, I would write the words mean value theorem. You can abbreviate, they don't care. And then on the back side, here's what Ellie was asking. You should write if f is continuous and differentiable. You can abbreviate. So if f is continuous and differentiable, I'm giving you kind of the condensed version on some interval, on an interval. You probably should put that on some interval. then on that interval, at least one tangent slope will match the secant slope. See, there's only one secant slope, but there's many tangent slopes. Theorem guarantees that on that interval, at least one tangent slope will match the secant slope. That's the mean value theorem. Please, Aaron.
For the secant slope, do you have to take the secant slope of the n 2 points, or can you take it of any 2 points in the interval?
Any 2 points in the interval. Most commonly, they kind of make the problem a little bit easier in that they tend to design the problem around the endpoints. But no, any 2 points within the interval where you can find a secant slope that match, then you can find a tangent within that interval that would match. Please, Brooke.
The secant slope will always be the same no matter what 2 points you use?
Not necessarily. Like the mean value theorem, but talk with me, Brooke. From this point to this point, what's the secant slope, Brooke?
1.
-1, because it's going down. No, can you see it? So the secant slope there is -1. That means because this function is continuous and differentiable, that on this interval, this is Zaren's question. Now, this is what is important. Only on that interval can you find a tangent slope that will equal -1. You can't go looking on some other interval. Does that make sense?
Yeah.
Good. Brooke? Yeah. Please. Oh, hold on. Anybody else here? Stop that.